Hey guys, so today I'm going to do the lesson on what's known as theoretical probability. I know we talked about probability and probability in our lives, but there is this thing that lots of probability comes from, which is the theoretical probability. And it is the probability um, that an event might occur. So in this case, and when we talk about theoretical probability, it's always a prediction. So that's what I like to tell people when we talk about theoretical probability. It's just simply a prediction. It doesn't necessarily tell us what's actually going to happen, but it predicts what might happen and what might more have a chance of occurring than what would not have a chance of occurring. And that's what lots of the casinos and any types of games, they go by what might happen. When we calculate theoretical probability of event, you have to count the number of possible outcomes. Possible outcomes. And that just means like you're looking to see how many different possibilities could happen. So you have to know that many. You have to know that all are equally likely. So equally likely. And you have to count the number of successful possibilities. And I'll show you an example in a sec, but successful possibilities are the ones that you want to happen. So you're going to count all of them that are possible, and then all the ones that would mean that you are successful in whatever it is that you're trying to figure out. So when we go to the formula per se, it is the probability of an event is the number of successes over the total number of possibilities. So let's look at an example, because this example makes you kind of think of how theoretical probability actually works. And we're going to look at a standard deck of playing cards. When I think about a standard deck of playing cards, how many cards do we actually have? So if you count all the cards, they go from ace to up to king, and there are 13 cards for suits. So we have a total of 52 cards altogether. Now the question is, what is the probability of drawing a king? So if we think about how many kings there are in the deck of cards, there's a king of hearts, king of diamonds, king of spades, king of clubs. So there are 4 kings altogether. So if you go by our formula up here, which says the probability of an event is the number of successes divided by the total number of possibilities, our probability of getting a king is equal to 4 over 52. 4 cards are kings, 52 cards altogether, so 52 possibilities. Now, in probability, there are a couple things you want to do with your probability just to make it nice. They say that they want to put your probability in lowest terms. So in this case, 4 over 52 is not in lowest terms, but I know that I can divide both the top and the bottom by 4. And if I divide them by 4, I get 1 over 13. This is the lowest terms. I can't make it any lower than that. So when you say the probability of a king, it's not, you won't just say 4 over 52. You'll actually put it in lowest terms, which is 1 over 13. As a decimal, you can write your probability as a decimal. That's super easy to do. You're just going to take the top divided by the bottom. So 1 divided by 13. And when we do that, you get 0.0769. And then as a percent, we'll just take the decimal and multiply by 100. 769. So if we multiply that by 100, you get 7.7% approximately. So it's okay to say approximately 7.7%. This equal sign with the line over top is approximately, in case you didn't know that. Let's go to the next page. So here, let me fix it for you. Sometimes a tree diagram, or what's called a tree diagram, is helpful when listing all possible outcomes in a probability situation. So, for example, contestants in a carnival game spin pointers on 3 different spinners. The numbers that the first and third pointers land on are either added or multiplied, as determined by the second spinner. To win a prize, the result must be a perfect square. For each attempt, what is the theoretical probability of winning a prize? So I don't have the numbers on, so let me put them on. It's 1 and 2. This one is plus or multiply, and then 1 and 2 again. So here's how you kind of do a tree diagram. And you want to think about it as, what is the first thing you're going to do? What's the second thing you're going to do? What's the third thing you're going to do? And each of those things make up the branches of your tree diagram. So let me show you. The first thing, this is the first spinner. This is the second spin. And this will be the third one. So if we spin it first, you'll notice that you have a chance to get a 1 or a 2. So that is our first spin. If that's our first spin, when we go to do the second spin, we can get a plus or a multiplication. So if we first if we spin it and we get a 1, then our next spin could be a plus or a multiply. If we spin it and get a 2, our next spin could be a plus or a multiply. So that makes up our second spin. Our third spin, same thing. We could get a 1, then get a plus, and then get a 1 or a 2. A 1 and a multiplication, and then get a 1 or a 2. 2 plus. Next possibilities are a 1 and a 2, and the same with the last one. You could get a 1 or a 2. So it makes up all the different possibilities. And you'll notice when we do it, so this is 1 plus 1, 1 plus 2, 1 times 1, 1 times 2, 2 plus 1, 2 plus 2, 2 times 1, and 2 times 2. Now notice they're all different. And then what they want is if they're going to be perfect squares. So let's actually do them. That's 2, 3, 2, 2, 3, 4, 2, and 4. Now perfect squares are those numbers that are like 1 times 1, 2 times 2, 3 times 3, 4 times 4. So 1 is a perfect square because it's 1 times 1. 4 is a perfect square because it's 2 times 2. So let's just highlight those ones that work. Oh my goodness, guys, I got this one wrong. 1 times 1 is 1. So this is one of them. Oh, shoot. Let's not do that. I wanted to highlight it. So here's one of them. That's a 4, which is a perfect square. And this is a 4, which is a perfect square. So we got 1, 4, and 4. Those are all perfect squares. The rest are not. But the question is, for each attempt, what is the theoretical probability of winning a prize? So how many possibilities do we have altogether? So if I count them, 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 possibilities. And how many are wins? We already highlighted them. We've got 1, 2, 3 wins. 3 prizes if we win. So what's the probability of winning is actually equal to our 3 successes divided by our 8 possibilities. So that's how a tree diagram works. This comes into play a lot. Like you're going to want to do a tree diagram with heads or tails, so flipping a coin. Or it comes up a lot if you're looking at families and whether they're going to have a boy or a girl versus a first child, second child, third child. So it comes up with all the different possibilities. So that's where you might use it. Let's move on to the very last question, which I say is the question of the day, which is something I do in my face-to-face classes, but we'll do it here. A vending machine at a video store contains different colors of gumballs. When you put in a coin and turn the handle, one gumball drops out. If the ball is white, you earn a free movie rental. Yay! When Alyssa puts in her coin, the machine contains 10 pink ones, 11 blue, 8 green, 14 yellow, 15 purple, and 2 white. What is the theoretical probability she gets a pink gumball? So we need to find the total. That's the first thing. So we'll add them all up. We've got 10 plus 11 plus 8, 14, 15, and 2. And I get a total of 60 gumballs. So what is the theoretical probability she gets a pink gumball? There are 10 pink ones and 60 total. And remember, I said you need to make it the smallest possible. So 10 over 60 is actually 1/6. So you have a 1 out of 6 chances, or 1/6 probability of getting a pink gumball. What is the theoretical probability she gets a blue or a yellow? So in this case, you're going to add up the blue and the yellow. We already know there's 60 total. But we've got 11 blue ones plus 14 yellow. So 11 plus 14 gives us 25. So 25 out of 60. You can also then reduce that because they can both be divided by 5. And I get 5 over 12. So you have 5 over 12 probability that she's going to get a blue one or a yellow one. What's the theoretical probability she wins a free movie rental? How many, in order to get a movie rental for free, the ball had to be white. You can get that from there. So if we go, we say, well, how many are there? There are 2 white ones. So 2 out of 60. And I'll reduce that to 1 out of 30. So 1 out of 30 chances that she's going to get a free movie rental. The last one gets you to kind of think backwards. What color of gumball does Alyssa have a 1 in 4 chance of getting? Explain your answer. So if the probability is 1 in 4, what does that translate to out of 60? Because that's our total. And if you think about it, 4 times 15 gives us 60. So we're going to times it by 50. So it's 15 out of 60 would give us 1/4. And there are 15 purple gumballs. So that one takes a little bit of extra work. You kind of got to go a little bit backwards. But that's the type of questions you're going to get with theoretical probability. So go ahead and enjoy. Bye, guys.